Standard 10 Maths 1 problem set 3 13th question. If m times the mth term of an AP is equal to n times its nth term, then show that the m plus nth term of an AP is 0. Now we'll see what is given. The m times the mth term means Tm, and m times is equal to n times, that is you have to multiply by n of its nth term. Nth term means Tn. The given sequence is an AP with A is the first term and D is the common difference. Now it is given that the m times, that is m multiplied by mth term, is equal to n times the nth term. So we know the Tn formula. So we have to find out m into T. We know it is given n into Tn. Now we know the Tn formula. So by that we'll write the Tm. This is Tn formula is A in the bracket n minus 1 into D. So Tm will become A in the bracket A plus m minus 1 into D. This is n in the bracket A plus n minus 1 into D. I will multiply this A plus m minus 1 into D is equal to Na plus n minus 1 into D. Now we bring this on the left side. This is Ma and Na I will write together. Ma minus Na plus m minus 1 into D minus this term is equal to 0. Now in this two term A is common. So in the bracket m minus n plus. Now in this two term D is common. So we'll write that D behind and we'll write these two terms first. Minus n minus 1, and we'll write this in the square bracket, and D is outside is equal to 0. Therefore A m minus n plus, now we'll multiply this m square minus m minus n square plus n into D. Write this as it is. Now we'll write this together. M square minus n square minus m, this is minus m plus n is equal to 0. Now here we'll use the formula of x square minus y square, x plus y minus x minus y. So m plus n, m minus n, these are the factors of this. Now in this we'll write this in bracket. So minus is outside m, and as we are writing the minus outside, this plus n will become minus n. We'll write this as it is. Now in these two terms, this m minus n is common. So m minus n I am writing. So in another bracket, whatever left, that will write. So m plus n is here, and here nothing has left, so minus 1. Will multiply by D, m minus n plus n minus 1 into D is equal to 0. Now we have got two terms again, and in these two terms this m minus n is common. So in other bracket A plus, A is left over here, plus, and this is left in the second term, m plus n minus 1 into D. Therefore it gives that m minus n is equal to 0, or this first term is equal to 0, or this is equal to 0, or A plus m plus n minus 1 is equal to 0. But m minus n cannot be 0, Therefore a plus m plus n minus 1 t is equal to 0. So this first term cannot be 0, so this is equal to 0. So we have got this value as 0, so we'll give the name of is equation number 1. Now we have to show that the m plus nth term, that is t m plus n, is 0. That we have to show that. Here we will mention that show that t m plus n is equal to 0. Now using the same formula of Tn, we'll write the formula for Tn plus 1. So Tn formula is a n minus 1 into d. So here it will become a plus, in place of n we have to write the m plus n. So m plus n minus 1 into d. Now this we have got directly over here as 0. So this is 0 from 1. So this only we had to prove. So the final answer is m plus nth term of an AP is 0.